All right, well, let's get started. Welcome everybody to our first lesson on calculus. So this is going to be an 8-week course, so it's going to be running over 4 weeks, and then we will begin our exam revision, and hopefully all of you guys will be in tip-top shape as far as calculus is concerned. I'm not sure whether you're going to be doing everything in calculus before your June exam, whether they'll get to the min-max problems. We'll just have to wait and see how it goes. And maybe we might have to start our exam revision a little bit sooner. I don't know. But at least if you are coming to boot camp, then you're going to get those 3 90-minute sessions. That's going to help you a lot for your exams. Okay, so the very first question that we get asked in any calculus question, in any exam, whether it's our June exam, our trials exam, our end of year exam, is always a question on differentiation by first principles. Once you've done differentiation, please mute. Desanda, please mute. Thank you. Once you have done after you do differentiation by first principles, you then learn how to differentiate using rules. And then all the matrics ask the same question. Why did we have to learn first principles if we can just learn the rules? The truth is that because there's always a question on it. Okay, so we've got to show you where differentiation comes from and then go on and learn about the rules. There's always going to be a question on first principles, and it's a level 1, level 2 type question, which means that these are 4 or 5 marks that we all want to get. Okay, so it's always going to be asked. It's an easy question. That's why we have to do differentiation by first principles. We need to understand what differentiation is, what it means, and what we're actually doing. Okay, so let's begin our lesson there. If I asked you, what does differentiation mean? What would you tell me? What do you know from calculus at school? If somebody said to you, if I didn't know anything about maths, if Yolanda didn't know anything about maths, and the question was, what is differentiation? What would you tell us it means? So you can pop it into the chat matrix, or you're welcome to unmute and speak if you'd like to. Put up your hand first. What does the word differentiation mean? What do you guys think it means? Okay, Nhlanhla, is it related to finding a gradient? Good, well done, Nhlanhla. Amahle, go for it. You've raised your hand.
Good evening, ma'am.
Good evening.
The differentiation can be another word for the derivative of the function.
Absolutely. So what does the word derivative mean? You're quite right.
I'm not sure.
You're not
I'm
sure.
not sure.
Okay.
No,
but
I'm just
you're
looking
quite
at my
right.
notes from school.
No, you're quite right. You can use the word derivative as well. Okay, in the chat, does everybody see that Nhlanhla said there, is it related to finding gradient? Okay, so we've got this word gradient. Okay, let's write that down. Any other ideas? Derivative or gradient? Okay, so let's talk a little bit further about this. If I ask you, okay, let's see, somebody's put something into the chat, f prime x, yes, Linda Kuchler, you're quite right. F prime x is the notation that we use when we're talking about differentiation. Absolutely. Okay, so Linda, very nice formal definition there. Derivative is the gradient of a tangent to the function at a point on the curve. Yes, very nice. So another way of saying that in easy language, all right, is that we are finding the gradient or determining the gradient at a point. So differentiation means, okay, to determine or find not that we use the word find anymore in maths, to determine the gradient of a function at a particular point. Right. Now, the reason that we would want to differentiate or find the derivative or determine the gradient at a particular function or at a particular point in a function is to understand how the gradient or derivative is changing depending where on the function we are talking about. So let's consider something that we know. All right, let's draw a parabola. Right? If I draw my parabola like that, if I am situated over here where I make a green dot, is my gradient positive or is it negative? Where the green dot is gradient positive or is it negative? Okay. So a lot of you have said negative, and Nhlanhla has said positive. Nadia says positive. Siba says negative. Okay. So those of you that are saying positive are correct. Okay. So the gradient is positive. X is negative at that point, but the gradient is positive. When gradient is positive, it basically means that as you walk from left to right, so as X is getting bigger from left to right, you are walking uphill. Okay. So at the green point, the gradient is positive. Okay. Because we're walking uphill. So here, gradient is positive. If I'm now on the other side, let's say where the yellow dot is, all right, if I'm walking up a hill from left to right, when I get to the yellow dot, am I walking uphill or am I walking downhill? I'm walking downhill, aren't I? Walking downhill. So here, gradient, which is the same as f prime x, here it would be negative or smaller than 0. So if we just take a parabola, something that we're all familiar with, the gradient changes from being positive to being negative. When I get to the turning point of the function, so when I get to this point over here, I'm not walking uphill and I'm not walking downhill. I've got to the highest point of the mountain. So we would say at the turning point, so at your turning point, your gradient, which is the same as the derivative of x, is now equal to zero. So the gradient changes depending where on the curve we are, at which point we are. All right, so the whole idea behind differentiation is the idea to understand what the gradient is at a particular point. When we are talking about a straight line, the gradient never changes. So let's draw down here. I was going to use this to explain something else, but anyway, never mind. Let's do this. If I talk about a straight line, like that one over there, if I say that this is the line y equals 2x plus 2, or let's make it something else. Let's make it 2x plus 1. We're not working with the same numbers. The gradient of this line is 2. Okay, it's this letter over here, m, from y equals mx plus c. So in other words, if I started down at the bottom over here, okay, there's us, and we're walking in that direction, the steepness of the slope does not change. It's the same the whole way. So if I find the gradient over here, or if I find the gradient there, or if I find the gradient there, or if I find the gradient there, it's not changing. It's the same at every single point. That's on a straight line. But when it comes to a parabola, the gradient changes. So in other words, if I draw a parabola like that, over here, say where the purple dot is, it's much steeper than if I was over here. Now it's getting shallower. So the gradient is getting smaller. It's approaching 0. Once I get to the top of the parabola over there, gradient is 0 because I'm no longer walking up. I'm not starting to walk down. And then as soon as I get past that point, I'm now starting to walk downhill. So over here, I'm walking downhill, but it's not as steep. If I'm going over here, it's much steeper. Okay, if I go over there, it's steeper still. So the gradient changes depending where on the line I am when we are talking about curved functions. With a straight line, the gradient is constant all the time. So this is what differentiation is. It means it allows us to determine what the gradient of a function is at a particular point on the function. All right. When we are doing it by first principles, it means that we are using a formula in order to be able to do that. All right. So some other words for differentiation. Okay. So we can use the word gradient. Okay, we were given that word, I think, by Nhlanhla. So Nhlanhla, you said the gradient or slope of the tangent line to f at any point. Okay, there's the word gradient again. So in other words, how steep the function is at a particular point. When we start to look at application of this, we're talking about the instantaneous rate of change at a particular point. And then a word, I think it was you, Amahle, you said the derivative. So all of these words mean the same thing as differentiation. Okay, it all mean finding the gradient at a particular point. So if we want to find the gradient at a particular point, there is a little bit of a problem. And mathematicians like Isaac Newton got around this problem by doing something that was very, very clever. I'm going to show you what they discovered when they studied these functions in more detail. What I'm going to do is just make a little bit more space. There's gradient formula for us, and you're going to see where this becomes important just now. Okay, so who of you at school have done average gradient? Your teachers may have showed you average gradient when you were in grade 11. Does that ring a bell? Average gradient. Does anybody remember that? Oh, good. Oh, good. So there are some people that remember the words average gradient. Yes, William, I see you've got your hand up. Would you like to ask a question?
No, ma'am, I was just raising my hand because
Oh,
I was
just to
saying
say yes.
yes, ma'am.
Oh, brilliant. Okay. All right. Lovely. Average gradient. Okay. So let's take a parabola again. Okay, so what I'm going to do here is I'm going to draw a parabola. Now, it's going to look a bit weird, okay? Normally, a parabola is a nice arch shape like this, but I'm going to draw mine very, very wide like that, okay? And I'm doing it for a particular reason, so I'm just going to draw it like this. Okay, it's not the greatest looking parabola I've ever seen, but you guys understand what it is that I'm getting at. Okay, now, if I say to you that this parabola is the graph of y equals f of x equals x squared, we're all familiar with that particular parabola because it's the very first one that we studied when we were in grade 10. So we've all seen y equals x squared before. Okay. So the idea behind average gradient is this. Let's pretend I have a particular input. Let's say 2 goes in. What would I expect my output to be? If 2 goes in, if 2 is the x going in, what would my output be? Can anybody tell me? Lovely. Yes, f of x notation, quite right. Lovely, it would be 4. Okay, because y would be equal to 2 squared, which gives me 4. So my output would be 4. Lovely. Excellent. Now let's pretend a different number goes in. Let's say 6 goes in. So that's 6. What comes out, matrix? Lovely. 36 comes out. So 6 goes in, 36 comes out. If I want to find the average gradient between these 2 points, so in other words, this point over here, where x is 2 and y is 4, and this point over here, where x is 6 and y is 36, it's like me connecting those 2 points with a straight line. Okay, that's what average gradient does. It's like connecting 2 points on a function with a straight line. So in other words, if I had a straight line that went through both of those points, let's just see if I can move it slightly to the left. There we go. If I was connecting those two with a straight line, the purple line, then I could work out the average gradient. Okay, now average gradient means using gradient formula. Okay, so there's average gradient. So if I call this point over here point A, and I call that point over there point B, I could say that the average gradient of the function from A to B would be, subbing into gradient formula, would be 36 minus 6 over 4 minus 2. Okay, which would give me 30 over 2, which would give me 15. Can you see it's a positive number? Because as I walk from A to B, I am walking uphill. Okay, exactly. Right, does that make sense to everybody? Okay, so that's average gradient, right? So 30, so 36 minus 4. Oh, sorry. 36 minus 6, listen to me. 36 minus 4. Sorry, over 6 minus 2. Sorry, change in y over change in x. Let's just correct that. So that's going to give me, a different gradient. Beg your pardon. That would be 32 over 4, which would be an average gradient of 8. That's better. Okay. All right. So again, it's positive. That's because as I walk from A to B, I am walking uphill. Now, if I wanted to calculate the gradient at A or at B, this is where it becomes a problem. Because if I'm trying to calculate the gradient at a particular point, all right, if I sub into gradient formula, I end up with a strange answer. Okay, so try and imagine now, all right, that point B is moving back down the line and it wants to end up at point A. So I don't want to work out the average gradient between A and B. I want to work out what the gradient is at A. If I work out what the gradient is at A, there's a problem that emerges when I use gradient formula. And it's not so much as what happens to the numerator, it's what's happening to the denominator. So let's pretend, using gradient formula, I want to calculate the gradient at A. Sorry, let's correct that. Gradient at A using gradient formula. So I've now only got one pair of coordinates. I've got 2 and 4. So what would happen here if I was trying to work it out using traditional methods? I would end up with my change in y over my change in x. Now, as I had said, the problem here is not so much the numerator. The problem is the denominator. I'm going to end up with a value, any value, whatever it might be. Let's call it a. But at the bottom, I'm going to have 0. I cannot divide by 0 because then my gradient would be undefined. So if I try to calculate the gradient at any particular point using traditional methods, I find that my gradient is undefined and I can't determine what it is. Okay, here I got a nice answer of 8. Here it's ending up being undefined. So mathematicians needed to be really clever and try and figure out a way around this problem. So what they discovered was this, okay? If you have a particular parabola, so let's have a look at this guy over here. I can work out what the gradient at a point is if I draw a tangent to the function at a particular point. So let's say I draw a tangent to the function at that point over there. I can measure the gradient on the function at the point of tangency because it is the same as the gradient of the straight line at that particular point. If I had a tangent at a different point, so for example, let's say I've now got a tangent over here. Let's just move that guy a little bit closer. I can measure the gradient of the function at that particular point because it will be the same as the gradient of the line. Where it is purple, the gradient would be negative. Where it's pink, the gradient would end up being positive. And the value of how negative or how positive it is would change depending on where I draw my tangent. So in other words, when you have got a parabola, you have got an infinite number of places where you could draw a tangent. So it works best if we use something that's very curved like that. So I could draw a tangent to the function there, or I could draw a tangent to the function there, or I could draw a tangent to the function there, or I could draw a tangent to the function there. And at each of these places, the measure of my gradient would end up being different. Okay. So first principles is a way of us being able to do this, to measure the gradient at a particular point so that we don't end up with a denominator of 0 when we sub into gradient formula. Okay. Now, what they discovered or how they figured it out is this is what they did. All right. So let's get rid of the numbers and let's go back to the parabola that we were talking about in the beginning. What they do is they say this, is they say at x, at a, x goes in and y or f of x comes out. If I move over to the right-hand side, I could describe the coordinate at this point as x plus h. If I move h places to the right-hand side, so h just represents an unknown value, okay? An unknown number of places that I am moving to the right-hand side. What comes out when x plus h goes in? It's f of x plus h. Okay, like so. Right. What happens is this, is if I want to know the gradient at A, it's like point B, as I was saying earlier, moves down the line and it ends up on top of A. So what's happening to the value of H in this case is that H is getting smaller and smaller as B gets closer to A. So what we say mathematically here is that H is tending to 0. That means that as I move from B to A, the value of H is getting smaller and smaller because I'm getting closer to A. This is where our equation for first principles comes from. So we're using gradient formula. So the gradient of AB is the y at B minus the y at A over the x at B minus the x at A, except now we change our notation. We no longer refer to gradient like this. We give it a special symbol. It's called f prime x, but it means exactly the same as gradient. Palesa, limits are not part of the grade 12 syllabus. You have to understand what a limit is in order to do differentiation by first principles, but there's never going to be any tests, any questions on it in control tests or exams. Okay. So we say the derivative of the function, the gradient at a particular point, okay, is your limit as h tends to 0 of the y at b. Now let's go back and look at what the y at b was called. It was called f of x plus h minus the y at a was f of x all over the x at b, which was x plus h, minus the x at a, which was just x in this case. And then in the denominator, we have like terms. So what ends up happening here is we simplify those like terms. At the top, we've still got f of x plus h minus f of x. And at the bottom, x plus h minus x means that we have this h left over. Exactly. So this is your formula for first principles. And it's on your formula sheet. Now, everything that I have explained to you about where it comes from, your teachers would do at school. All right. You're not going to be asked questions on where it comes from. But it's nice to understand this in order for you to be able to understand that you're actually working with gradient formula. It's just that we've changed some of the notation, and now you understand where f of x plus h and x plus h minus x in the denominator, where it comes from. Okay, what they will expect you to be able to do is they will expect you to be able to work with this. And that's what our first question is going to be on. All right, so before we jump in and go and find the gradient of a particular function at a particular point, I just want to know, are there any questions on what we've discussed so far? Is there anything that you'd like to ask me before I move on and do the first example? Incl, yes. You're welcome to unmute, Incl.
Afternoon, ma'am.
Good afternoon.
Ma'am, I just wanted to ask about the if x plus h.
Yes.
Does that represent the y value in a way?
Yes, it does. That's exactly what it represents. So it represents the y at b.
Oh, okay.
Yes. So f of x plus h represents a y coordinate at another point on the function.
Okay, and f of x represents the other y value.
Exactly. Exactly. Okay, 100%. Well done. Okay. Lino, You're welcome to unmute.
Hello,
Hi.
ma'am.
Hello.
Hello, ma'am.
What did you want to
How
ask
are
me?
you?
I'm fine. How are you?
No, I was. Oh, I'm thanking you, ma'am. No, I
That's
was
good.
going to ask what Ntlanta was asking, so I found clarity on what you were saying. Thank
Okay.
you, ma'am.
All right. That's fine. No problem. Okay. Lusanda.
Hi, ma'am.
Hi there. How are you?
I'm good. How are you, ma'am?
I'm fine. Thank you.
Ma'am, I wanted ma'am to please repeat the formula again for me because I came back in late. I've been
Okay.
silent.
All right. So we're subbing into gradient formula. I'll go through it one more time before I move on. I just want to take Lebohang's question. Yes, Lebohang.
Oh, afternoon, ma'am.
Afternoon. How are you?
Good evening, you, ma'am.
I'm fine. Thank you.
Ma'am, I wanted to ask where it says f of x plus h, if there's a third value, is it f of fx plus 2h or there at the top there?
Where are you talking? Where do you mean when you say there at the top? Do you
Oh,
mean,
there's point B, ma'am.
pardon?
By point B, ma'am.
By point B, absolutely. Okay, so this f of x plus h represents the y coordinate at B. Okay, so that is the y coordinate at B. Okay,
Okay, ma'am.
that's what it means. All right. Okay, so we are subbing into gradient formula. Gradient is f prime x. So these two things are the same thing. Okay, so f prime x is another way of writing gradient. Right. Your limit as h tends to 0 means that point B is moving down the line to point A. And as B gets closer and closer to A, the distance between them, h, gets smaller and smaller and smaller. All right. But we are not allowed to say that h is equal to 0. Because if we say that h is equal to 0, then our gradient is going to be undefined. Okay, so we say that h tends to 0. As B gets closer to A, h tends to 0. So that means that the distance between them is getting closer and closer. All right. But we're not allowed to say that h is equal to 0 because we obviously can't have something that is undefined. Okay. Let's just see. There was something else in the chat here. Batabile. Okay, Yolanda, that was you. All right. So hopefully everybody has been able to take screenshots at this point. And what I'm going to do is I'm now going to show you how to sub into this formula and what our answer would be. It's not a particularly difficult thing if you know how to substitute. Okay, so there it is. That formula will be on your formula sheet. There's Yolanda smiling at us. And here is our first question. All right, so the question asks us to find from first principles the gradient of f of x equals 1 minus 3x squared at any point. All right, so what I like to do is this. I like to write down what f of x is. F of x is 1 minus 3x squared. Then what I like to do is I like to write down what f of x plus h is. So now everywhere that we had an x, we've now got an x plus h. So I'm going to substitute x plus h in place of x. So I'm going to sub in x plus h, and then I need to square it. This is algebra. All right. So what I'm going to do now is I'm going to say 1 minus 3, and then I'm going to square my binomial. So I'm going to say x plus h times x plus h. I'm going to leave my 3 on the outside. I'm going to keep my brackets because I still have to multiply through by -3, and I'm going to do FOIL. That's going to leave me with x squared plus xh, so that would be 2xh, and then last times last, that would leave me with h squared. Now I'm going to remove my brackets in the -3, and I'm going to end up with 1 minus 3x squared minus 6xh minus 3h squared. Okay, so do that first. Then sub into first principles. So first principles, f prime x is equal to your limit as h tends to 0 of f of x plus h minus f of x all over h. So we have to keep our limit notation, and I'll show you the point at which we drop our limit notation. Excuse me, sorry, Matrix. So now what we do is we're going to sub in. So in place of f of x plus h, we are going to write what f of x plus h is equal to. All right, so here I'm going to put in 1 minus 3x squared minus 6xh minus 3h squared. Then I'm going to minus f of x. Now, f of x is 1 minus 3x squared. So because it's a binomial, I've got to use brackets. So minus 1 minus 3x squared, like so, and all of that has to go over the h. Now, I'm not allowed to drop that h out and then put it back in again somewhere at the end. Okay, if you do that, they will end up penalizing you for it. Okay, so that is not allowed. What I'm going to do now is remove my brackets and keep my limit notation. So equals my limit as h tends to 0, 1 minus 3x squared minus 6xh minus 3h squared minus 1 plus 3x squared, and all of that is over h. Okay, equals my limit as h tends to 0. Can you see the ones cancel out? Can you see the minus 3x squared and plus 3x squared also cancels out? So all I'm left with is minus 6xh minus 3h squared over h. And now this is the really clever part. In order to get around my denominator being 0, factorization comes to the rescue. So yes, Linda Kuhle, we are going to take out h. We're going to be left with minus 6x minus 3h over h. My h divided by h is now going to cancel. Right, so what I am left with is my limit as h tends to 0 of minus 6x minus 3h. You are not allowed to show that h is 0. Okay, this is something that we do in our minds, but we're not allowed to write it on the page. So we are bending the rules, but we're not breaking them. Okay, so if h was equal to 0, then this term over here would not be there anymore. Right, but I'm not allowed to write that h is equal to 0. So once I've subbed in my head that it's equal to 0, but not on the page, what I'm then allowed to do is write down my answer. Okay, I drop my limit notation and I write down that my answer is minus 6x. I don't know why my minus did that weird thing. Let's just put the minus in, even if it's in a different color, it doesn't matter. Okay, Tsegovatso, go for it.
So, ma'am, if you are not asked to use the gradient the gradient formula,
Mhm.
can I also use the power rule?
Not for this question, no, you can't. So what you will see with any paper, there's always going to be one question from first principles, and then the rest of the questions you will do using the rule.
Okay.
Okay, so if you have a look here, all of these questions I have taken from your November papers. Okay, can you see it says determine f prime x from first principles? If it is given that f of x equals this, you've got to do it the long way. Same story here. This is from the paper the year before. Okay, from first principles, f of x equals 4 minus 7x. It's worth 4 marks. So you can see they are stipulating each time that you've got to do it from first principles. Okay, so they want to see this long method that I have shown you over here. Okay, all of us know what the answer is before we get started because we can use the power rule. So we know what the answer is, but we've got to show the working out. All right, so just very quickly, this is where the marks are allocated, and then I will certainly answer some questions. Okay, so there is always a mark for subbing in. Okay, there is often a mark over here for correctly changing signs. There is often a mark over here for simplifying accurately. There is always a mark for showing that h is factorized, and then there is a mark for the answer. Okay, so 1, 2, 3, 4, 5 marks most of the time. Okay, most of the time. No problems, Natile, off you go. Okay, so Nadia, the minus 3h disappeared because in our heads, we're subbing in that h is equal to 0. So minus 3 times 0 would give us 0. So we're not writing that. Okay, so we're not allowed to write that it became 0. Okay, if you do that, then they will penalize you. Okay, Lusanda, what's your question?
Oh, ma'am, you answered it. I just wanted to ask, in the place of h, you're gonna substitute 0 and then you don't
No,
need to show.
no, no, no. No, 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 no. You never, ever, ever show that h is equal to 0. Okay, because if you show that h is equal to 0 down here, then we can say, well, h can be 0 in our first line of working, our second line of working, and our third line of working, which makes it undefined. Okay, so never, ever, ever sub in the 0. Okay, that is something that you do in your head, but you don't do on paper. Okay, that's what I'm saying. You're bending the rules, but you're not breaking them.
Okay,
Okay,
thank you.
all right, no problem. Let's
is
just
it
have a it depends, Zonda. For first principles, yes, because the distance between the 2 points tends to 0, but it can tend to anything. Okay, but you don't have to worry about what it tends to, because that's questions on limits, and you're not going to do that. Okay. All right. So no mark for the correct formula is Simpiwe because there is no other formula. Do you need to show how you got f of x? Naledi, yes, it's a good idea. Okay, what you can do, Naledi, if you want to, is you can sub this line of working over here in there. But I don't recommend that you do that, because often what happens is that we get bogged down with the algebra, then we forget to put the h over at the bottom, etc., etc. So it's much better for you to work it out on the side and then go and sub in. Okay. All right. So now let's try one. Okay. So let's try one before you guys go. Okay, I want you to try this particular question, please, matrix. Okay, so you're going to determine f prime x from first principles. Let me just grab the formula. Sorry. And you guys try that one. Okay, and then we're going to mark it. Okay.
It disappeared. I'm not sure
so
what's
weird.
going on, but
That is so weird. Now
we
can
can
you see it?
Guys, yes. Guys, take
Is that
screenshot
better?
real quick
I can't see the box.
You
Ma'am,
can't
you can
see
just
it?
move the question down.
No, that is so weird.
Wow, we can see the box, but now they know that f of x is equals to minus x to the power 2, guys. Let's go. We can do this.
That is so strange. What if I move it there? Is that better?
We don't have the box in the board at this moment. I'm not sure.
Okay.
The box just appears out of nowhere.
It's funny because
I
I've
don't know
also
why.
seen like a box earlier that appeared, and I was like, what is this thing? I want to
Yeah.
know why. So if f of x equals minus x squared,
Yes.
f of x equals minus x squared. So you know what I'm going to do? I'm going to go down here. All right. So let's see if this is better. So f of x equals minus x squared. Can everybody see that?
Yep, we can see it.
Okay. And then there's your first principles formula.
We are good to go, my people.
Are
Let's
we
do
good to
this.
go?
Yes.
Okay. All right. There we go. Sorry, guys. I don't know where this comes from.
I'm not sure if Amahle and Amahle is gone, but Mihlali's hand and Amahle's hand is up and
Oh,
Tsogofatso.
okay. No problem. Who was first?
Amahle was first. Amahle, do you want to ask your question? And some of you can put it on the chat. I'll see if I can
Okay,
able to
thank you,
answer it.
ma'am. As a rule of thumb, can you just check the answer for the first principle using the first derivative?
Yes, using your power rule. Yes, you can.
Okay,
Yes,
thank
you can. Yes, absolutely. Sorry, Amahle, no problem. Okay, next person. Tsegofatso, do you want to ask something?
No, ma'am, I did not want to ask a question. I wanted to answer the question when everybody's done.
Oh, okay. All right, that's fine. Okay, so if you're done, just pop done into the chat. And then we can take it from there. Sure, some people. Oh, good. You guys are finished quite quickly. That was great. Well done. Okay,
Nice,
so I'm
my
just,
people.
all right. So I'm just going to scroll up. Oh, wow. You guys are finishing quite quickly here. Okay, I don't know where you wanted me to scroll up to, if this is the right place. Oh, wow. Done, 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 done. Done, done, done. I'm going to go back down again. Okay, so Tsegofatso, what did you write?
So, ma'am, I first wrote the equation before I can substitute.
Okay, so you have f of x. What did you do with f of x plus h?
Then I got negative x squared minus 2xh minus x squared.
Okay, so minus. Okay, and then here you ended up with negative, and then you had x plus h times x plus h. Is that correct?
Yes.
And then you ended up with, you said x squared plus 2xh plus h squared, and then you got minus x squared minus 2xh minus h squared. Is that correct?
Yes.
All right, lovely. So now when you subbed into first principles, into the formula, what did you have?
Then where it's x plus h, I substituted the equation I got. The one with
Okay,
negative x squared minus 2xh minus h squared minus,
lovely,
then into brackets, negative x squared.
lovely. Well done. And then all of that was over?
Over h.
Lovely. And then in your next line, you wrote?
Then the negative x squared will cancel the other negative x squared in the bracket.
Correct. So what would you end up with here?
Negative 2xh
Mm-hmm.
minus h squared divided by h.
Beautiful. All right, next line, what did you do?
Then my common factor is h.
Lovely.
So it's negative 2x minus h all divided by h.
Lovely. Good job. Keep going.
Then the common h will cancel the other h that is dividing the equation. So
Mm-hmm.
I'll be left with negative 2x minus h.
Lovely. And then you had?
My final answer is negative 2x.
Beautiful. Okay, and you would have dropped your limit notation and you didn't show that h was equal to 0. Good job. Well done. That's excellent. Okay, how did you guys do? All right, was that okay?
Well
Did you get
done,
it? Good.
guys.
Well done.
Well
Well done,
done.
Matrix. Okay, so now you need to answer the poll.
Yes, please.
Then I also would like you just to take a couple of screenshots. I've got 2 questions. Well, actually, you know what? I'll just give you 1 question for homework. I'd like you to do 7.1 for homework, please. Okay, so this is your homework, and then I'll put this up and mark it next time. Okay.
Get the comment. So homework.
Okay, Maklatse, I'm going to go back down screenshots, everybody. Please do the poll after that.
Ma'am Yolanda,
Yes.
ma'am, can you please send me the link like a bit earlier on Thursday? I'm Lusanda, because I struggled today to log in.
Yes, Mitlali. If you sub in 0, they'll deduct marks.
Sorry, so the link gets sent by our administrator. You should find it on your WhatsApp, the link to
I
join.
find it like a bit later. I find it like a few minutes before 5 and I struggle to log in every time.
Oh, I'll definitely just try and see if they can't look into that. But also you can definitely tell the administrator. I'm not sure if they will be able to assist you because they're the one giving out the login details, like the link details. So I also don't
Okay.
have the link for you, but I think if you can talk to them and then you can find out why. But also just know that the reason maybe you might be struggling, it could be network, it could be that we are also not on, or we are not letting you in because it's not 5 to 5 yet. Because we only allow people like 5 to 5, then we can allow you in.
Okay, thank you, ma'am.
Okay. Yolanda, what I'm going to do, I'm going to go.
Yes, please.
And then I'll go and start. And then if you've got that, you can find, sort of just finish up and see if they've got any more questions. Let me just make you the host
Yes, the
quickly.
co-host, please.
Where are you?
Close to where you are.
Oh, there you are. There you go. Found you.
Thank you.
Okay. All right. And then I'll see you guys on Thursday.
Okay. Thank you, Tikali.
Thank you. Bye, everyone.
Bye. Okay, so guys, basically what you need to understand, I think I saw some of the questions here about why was it like a minus and then in bracket x plus h to the power of, in brackets to the power of 2. Remember that whenever you have f of x, we are replacing f of x with f of x plus h inside. And then if we had negative x squared, we will replace the x with x plus h. So that's why we had a negative open brackets x plus h all to the power squared. Okay,